Hello everybody, welcome to chapter 3. Today we're going to talk all about plotting. So you saw an example of plotting before in the previous lecture, I think chapter 2. So today we're going to look a little bit more in depth. Okay, so let's take a look. So there's additional plotting features for two-dimensional plots. Okay, we're not going to talk about three-dimensional plots, which you can absolutely do in MATLAB. Can't remember what chapter that is, but it's coming up. Okay, well, we're not going to talk about that till then. Okay, so let's just look at the basic plotting function here. We've already seen that we have, the basic plot, which plots x and y data on linear axis. So if we just look at some data, so I'm going to say x equal 0 in steps of 0.1 all the way to 10, right? Then I get this vector. Again, I like to look at it as a column, right? That looks a little nicer to me. And what I did to get that was I just put this little tick mark. See the little tick mark? That transposes it from the default in this format to the column vector format. Okay. So let's say now I want to say y is equal to x squared. Now notice that I have to use the dot operator, because what that does is it'll take every single value of x and square it and put it all into y. And see, there we go. And because I said to do that with x, which was already a column vector, y was a column vector. So that's really nice. Okay, so if I just say plot that, right, so plot x, y, what do we get? Well, there you go. I went from 0 to 10, right? So what do I get? I get y equal 100 at 10. Okay, so this is just half of a parabola. And of course, if I wanted the other half, I could make my x go from minus 10 to 10, right? And I have to redo y. Okay, so that's just the basic plot. Okay, so what if we plotted this on a semi-log plot? So what does that mean? Well, semi-log x plots x data on a logarithmic axis, so that would be this on a logarithmic axis, and y data on a linear axis. Let's just try it for fun with that data. So semi-log x, x, y. There we go. All right, so look at the x is now on a log plot, right? And you can see, so what kind of log is it? I hope you can guess that it is a log to the base 10. Okay. And if you can see, the y is still going from 0 to 100. Now semi-log y will put the y-axis on a log plot. There you go. So look quite different. Now x is on a linear plot and basically just takes the log of all those values. Okay. Okay. Fine. So now log, let's try log. That'll be fun. That puts them both on logarithmic axes. I tend not to use these. I tend to just take the log of my data and plot that using a regular plot. But you can use this if you like. Okay, there you go. All right, so log, and that should make sense to you because we had, a function y equal x squared. If you take the log of both sides, you get log of y equal log of x squared, which is just 2 log of x, right? Review your logarithms. And so you get a linear plot. Okay, so that's kind of fun. I very rarely use these because I would just take the log of my data myself and then, take the log of x and then plot that in just a regular plot. But it's kind of helpful just for quick stuff, and I think a lot of people do use these functions. All right, let's look at controlling the plot limits. Okay, so let me put this over here where you can see it. All right, so here, let's go back to our regular plots. I want to plot our regular plot there. Okay, here we go. That was just our y equals x squared plot. But let's say we'd like to only show from 0 to 2 here, right, on x, right? And then we want our y to just be, say, from 0 to 50. Okay, you can change those axes. I'm going to put this down here, see if you can maybe see more of it. not the easiest thing to deal with. Okay, and so just to get what the axis is now, this does not need to be this big. Okay, there we go. To get what the axis is now, so we say axis, well, I'll say V equals axis, just like we have up here in the PowerPoint. What does it tell me? It tells me that X goes from 0 to 10, and that Y goes from 0 to 100, right? That's what it tells me. And this V is actually a vector of values. Now I can change this by using the axis command. So I can say axis, and then parentheses, and then I need to give it a new list, right? So a new vector that has the minimum of X, the maximum of X, the minimum of Y, the maximum of Y. So I want to go from 0 to 2, whoops, sorry, I need space, 0 to 2 and 0 to 50 for the Y. And there you go. And you can see what happened. Look how the Y certainly didn't need to go to 0 to 50, right? It really should have gone to 0 to 4, but I just wanted to illustrate the point. So you can see now X only goes 0 to 2. Okay, and I can just put it back, right? So I'm going to put it back by telling it to do axis V, because V still has that original limit. There you go. So now it's back. Okay, now axis equal puts the axis increments equal on both. So let's just see what that does to our plot. So axis equal. Yeah, so that isn't great, right? So, and for some reason, so sometimes this isn't the best thing in the whole world. It has the increments equal, but it decided it needed to go negative for some reason. So I'm not sure why it would do that. I never use axis equal. Axis square basically makes the whole thing look square. So sorry, square, right? So now it's, because you notice that when we did the plot originally, it had sort of an aspect ratio, was kind of rectangular. This just squishes it to a square. It hasn't done anything to the limits really. It just makes it look square. And sometimes when you're plotting something that you expect to look, say, circular, right? MATLAB will make that aspect ratio like a rectangle, and so now your circle looks like an oval. So axis square will make it look right? So sometimes you need that, sometimes you don't. And axis normal just kills all the effects of axis square and everything. So let's just go back. There we go. See how that's got an aspect ratio of a rectangle? Not great if you were trying to plot a circle, right? Okay. And axis off just sort of takes everything off so like this, so axis, right? So you don't have any tick marks or anything. And that is actually very useful when you're building plots. I mean, you probably won't get to that here, but certainly when I'm building graphical user interfaces, I might need to do this. If I have special things that I just don't want that white background and I want those tick marks, I'll use this, but I can turn it back on. Okay, so it's back on. Okay, let's go on to the next one here. Now, you can make multiple plots on one graph, and there's several ways to do that, and we'll see a second way further down in the slides. But the easy way to do this is just to, let's say I now want to plot, I have x squared, and I want to plot x cubed on there as well, but I want it on the same plot. Well, I can just say hold on, and that's a toggle, right? So I can say hold on and hold off. Hold on says whatever the figure is that you're working with, it says just leave it there, don't erase it when I give you another command. Plot whatever I want to plot on top of it. So let's make a y cubed variable equal to x dot cubed. Oops, sorry, I didn't put the dot. There we go. And now we're going to plot that right on top of this graph. Plot x, y3, and I'm going to plot it in red so you can see it. There you go. And of course it rises much more quickly than x squared. Okay. So with the hold on, I can keep plotting stuff on here, right? And that's very useful, but you can also just turn it off and then it'll just rewrite the plot, right? So if I turned it off, say hold off, it's just going to rewrite. When I plot something else, it'll just rewrite the whole figure. Okay. You can also put up multiple figures. So right now, the default is figure 1 that comes up when you say plot. But I can actually invoke a figure, and I can tell it what number I want, and that's often very useful. So let's say I want it to be figure 100. There you go. And now the next thing, as long as you've clicked on to figure 100, when I plot, so here, let me plot my thing here, it'll go on to figure 100. If I go over here, right, and then my plot would go on to this. And this has got to hold on, this one does not, okay? So if I try to plot on my, so I'm going to plot now, I've clicked on to figure 100, and I'm going to plot my x versus, y versus x squared. See, it changed it, right? Because the hold is not on that figure. The hold goes with the figure, okay? So you have to click on it. That makes it what's called the current figure in MATLAB. And there are ways to do that programmatically. That means with a command, right? But that's a little advanced. You don't need to know that. Just click on the figure you want to plot on, right? And then you can say, hold on this figure, and it'll only apply to this figure. And like we said, the hold is not on this figure. Okay. That's how you get another figure. Okay. We can make subplots, and that's often, I do that a lot. And what you do is you'll just say, you know, let's clear the figure. So CLF will clear the current figure, which is figure 1 now, because I just closed figure 100. So it's cleared. So now I can say, you know, subplot, and I'm telling it how many I want, right? So it says it's an M by N equal sized regions, right? So say I want 2 by 2, and I want the first plot. So I'm going to say subplot 2, 2, 1. So that's going to be the first plot. There it is. And I haven't plotted anything in it yet, so I can use my plot command. But now my plot command will plot in that subfigure. Okay. Let's plot our first one. And now let's get another subplot. Subplot 2. There you go. And now let's plot our y cubed variable. Hello, y cubed. Where are you? There you are. Okay. So you can see, and you might, you know, in the subplots, you might want to make sure that the axes are all the same for all the subplots. So I don't know, whatever you're doing. And then, of course, the third one will be there, right? And I can plot something there, etc. So, right? But you can make many subplots, and I have graphical user interfaces in which I have, you know, like 16 subplots per plot. So they get pretty small, but depending on what you're doing, you might want to do that. Okay, so let me show you just one of those my graphical user interfaces, just to show you what that looks like. So just for fun, because I just talked about subplots, and it's yelling because I'm doing this. Yeah, you'll get used to that sound. It's annoying. Yep. Whenever it makes an error, that's the noise you get. Fun times. Okay, so let me show you. So USB. Okay. Okay, it's going to ask me what I want. This is fine. Yes. So I built all this GUI. So graphical user interfaces are called GUIs. And what it does is it's plotting some ultrasonic sound. Okay, and I can change, I built all these sliders and all the things that you see here. And it's very useful because you can, you know, do things that allow the user not to have to interact directly with code. So the user doesn't have to like run a bunch of code. The user can click on buttons. Okay, so I'll click on visualize here. And you can see my little subplots here. And it turns out there's only 2, these are little calls that mice make in the ultrasonic range. So this is kilohertz. So this is, you know, probably about 60 kilohertz, so way above our hearing range. And this little subplots show you the plots, and there's only 2 of them, so it doesn't show you. And there's things that you can do like delete, or you can find this in the main thing. So it just will scroll over to that particular call, etc. So GUI, these graphical user interfaces, you can write really powerful ones in MATLAB, and it helps you. You know, I didn't really write this for somebody else. I kind of wrote it for myself because I have to process lots and lots and lots of data, and without an interface like this, it would be absolutely impossible. So anyway, just showing you. But you can see there's subplot, right? This is a subplot of 4 by 4, so 16 little plots. Okay, I'll get out of the GUI. Okay, just to show you. All right, let's go to the next thing. Now, the cool thing about, I was telling you before that MATLAB has such powerful ways of dealing with plots. You can customize those plots within an inch of their lives, and there's really no other program that can do that. I mean, there really isn't unless you write one yourself somehow, right? So it's really great, and you're going to see just a couple of little things here, but there are hundreds of things that you can use programmatically, that means with lines of code, to make your plots look the way you want to. And you saw in my graphical user interface, I've done a lot of that. Maybe you couldn't tell that, but I can control every aspect of the plots. Okay, all right, so let's just look at something called line width. So let's do our plot again. Plot. There we go. So I'm plotting the x cubed one. And let's say I want to change the line width. Okay, so change the line width. I'm going to look down at the command line here. I'm going to put in this command line width, and it does not have to be capitalized. Even though it says it's capitalized there, it's not. You don't have to. You say line width, and then you say what you want the line width to be. So all of the things that you use to change plots come in these pairs. Okay. So they come in like property name and the value that goes with the property name. So line width, and I want to put 2. Okay, so let's see what that does. So it makes it thicker, right? So let's go back to line width 1, and that was even thicker than we had before. So I don't actually know what the line width is. I can find out, and I'll show you that probably later. You can find out what the properties of your graph are, and maybe I'll show you now. Let's see. So show all properties. So I can say, all right, look at all the properties of my graph. So all of these properties you see are just the properties of the graph itself, not actually, well, not actually the data, but all the properties of the graph. So you can go down here and see, do they have line width on here, I think? Yeah, I don't know. This is probably a property of one of the children, which is the actual graph itself, so the line. So let's see if I can get, ignore what I'm doing right now. Let's just see if I can get it. Yeah, so you'd have to get one of the children of the graph. So there's a so the children basically is there's a child of the graph, and that's the actual graph itself. So let's see if I can get that. Okay, show all properties. And now maybe we can see line width. This is more than you need to know, FYI. I just want to see what the line width is. Yeah, line width is set at 0.5. Okay, so that is the normal line width of your plots when they come up. Okay, anyway, but you can set your line width when you make the plot. You can also set it later. You can set it anytime you like. So let's see, line width 6. Really thick, right? So you can do all kinds of things like that. Marker edge color. So if I wanted to make a plot with a certain marker, and the markers kind of come in with the, do you see how it says quote red, quote R? There are a bunch of colors that have shortcuts like R, G, B, right? So for red, green, blue. So you can tell it you want green. So let's say we want green. And oops, my quote went away. It needs to be in quotes. But you can also tell it what kind of marker you want. So let's say I want the star as a marker, right? It's going to put a star at every point, and that looks pretty bad, right? Okay, but what if I wanted, because I have my line width is so thick, so I'm going to go 0.5. There we go. So there's the stars. And because I've said I want stars, so look down here. I hate that thing. So look down here. Because I have the star, and I don't have a little dash anywhere, it's not connecting the points. We saw that in the last lecture. So you want to put a little dash, we want the points connected. Looks a little bit nicer. But I have other markers I can use. And in fact, there's one, if I put S for the marker, I get, and you can see, we're going to, let me make this much bigger. Can you see? They're little squares. It's a little square, okay? And I can make the marker edge color of that square a different color. Okay, so let's see. Let's try that. So I have our line width 0.5, and I'm going to have marker, marker edge color, and then I'm going to put red. And there you go. Notice how my line is still green, but the edge of my marker is red. Now you can also fill the marker with a different color if you wanted to. So there's all kinds of things you can do to make your plots, interesting. We can change the marker size. Why don't we do that? Let's change the marker size. So we've now got our marker size. Now I notice that every besides this one, which is kind of a built-in thing, when you want to change a property, you have to say the property name, and it doesn't have to be capitalized, but it does have to be spelled correctly. And it's never two words, it's always one word. And then the value you want that thing to be. And then over here we have marker edge color, we want it to be red. And you have to know what kind of values it will take, okay? Marker edge color will take the shortcut things like RGB, there's like 5 of them. But it'll also take a vector of RGB values scaled to 1. We can talk about that later, but anyway. All right, so now I want marker size, and I'm gonna say, I don't know, I'm just gonna guess something, 3, and see what happens. Ooh, look how tiny they are, right? Cool. All right, so let's do 6. That looks like the normal size. And 10. There we go. So you can change the size of the marker. So there's so much control. This is just the very, very tip of the iceberg for MATLAB's plots. Okay. All right. Let's look at some other kinds of plots. There are polar plots. I think I've used this one time when I was making polar plots of some Alzheimer's activity data. But let's just take a look. So I'm going to make some polar data. I'm going to make theta equals 0 in steps of 0.1 to 2 pi, 2 star pi. Okay, so there you go. I'm making a theta, and I'd like it to be, there we go, that's a little better. That's 2 pi. And then, well, okay, and then we're going to do we're just going to make a polar plot, of theta and r. Actually, let me make r here. R equals, and let me, so what we would like to do here is, remember, when we're using plot, we have to have the same number of items. So if I just said polar of theta and then 2, it's going to be like, nope. Both theta and r have to have the same size, right? So if there's 100 values of theta, there has to be 100 values of r. Now if I would like to just plot a circle, right? So I want my radius to just be like 5 or something, right? So to do that, there's a really easy way. What you can do is you can say r equal 5 times the special function 1s, and if I say size of theta, it'll grab the size of theta, so it knows that theta is how many long, which I can't remember, and that it's just a column vector, and it'll give me 1s, that many 1s in a column vector, and then it'll multiply each value by 5. Okay, there you go. All right, so let's do polar of theta r, and look over here. There we go, and notice it's a circle. And let me change, I'm assuming, I've actually don't remember given this thing, but let's see if we can change the color. Yep, there you go. So there it is. It's a circle, right? And let's put the points in. I'm going to put little squares. There you go. There's all the points. And I want it to connect, so I'm going to put my little dash in. Okay, there you go. Okay, so there's a polar plot. So why don't we try something a little more interesting? Let's do the cosine of theta. Oh, r cosine theta. R star cos theta. Now notice the cosine theta is, the cosine is actually taking the cosine of everything in theta and returning a column vector the same size as theta of the cosine of everything, and then it's multiplying it by r. And we have to be careful here because I did something wrong, and that is that r needs to be point by point multiplied by theta, because there's, let's say, 100 r's, right? And there's 100 cosine thetas, and I need to multiply them point by point. Otherwise, it's going to yell at me. Now, of course, r is just 5, so I could have just put 5 times cosine theta, and that would have been just fine. But just pointing out here, there's 2 ways to do this. Okay, there we go, and there is the cosine of theta. So really cool. So polar plots are fun, and I've done a bunch of them for, like I said, for one time. And most of the time I don't need them, but nice to have. Okay. And there's additional stuff like bar, which makes bar plots, and I'll let you guys play with that. Compass, which I've literally never seen, but it's very cute. So just for fun, let's do compass. So I'm going to make a new X, and I'm just going to make 5 points. 1, 2, 3, 4, 5. And then I'm going to make, actually, sorry, yeah, so it's X and Y. So let me do that again. I'm going to make a theta first. So theta, a new theta, and I'm just going to make it 5. You know, I'm going to make it short. So 0 to 2 pi in units of 1. Yes. Oh, yeah, 2 star pi, yes. By the way, did you notice what MATLAB did? So I forgot the star, and MATLAB was like, nope, nope, did you mean this? So sometimes it'll correct you, and it'll correct you correctly. So that's kind of nice, and you can just push enter. So there we go. There's theta in units of 1, okay, or steps of 1. And now I'm going to plot, so I'm going to do compass. Wow, compass of 5 times theta. Sorry, 5 times the cosine of theta, because I want x. And then 5 times the sine of theta, because I want to plot these. Well, you'll see what it is in a second. So look at this. So it's points, right, that are 5 away from the center, right? And it's plotted in Cartesian, right? So I had to convert here to, you know, r cosine theta, r sine theta, and it makes these little arrows. So I've never seen that. I think it's very cool. All right. Okay, so there's additional stuff, and I'm not going to show you all this, but what I will do is just show you the help for pi. So that's really kind of cute. So if I'm going to go to my resources tab here, and I'll type in pi for pi chart, and you can see it tells you all about it, and then it gives you an example, and you can even do this at pi explode. So you've seen that probably somewhere, you know, graph somewhere. So kind of cute, nice stuff, right? Okay. So ways to use that. And you can look these up as well in the same way to figure out what those things do. Okay. Now, remember I told you there was a couple of ways to plot 2 things on one plot. The second way I'm going to show you, I literally never use, but it's worth doing. If you say x, let's get our original x here. Okay, I had to redefine it because I had already overwritten it. All right, and then I have our y, right? I have y, which is y equals x squared, and y3, which is y equals y cubed. And what I'm going to do is put it into an array. yr equals, and I'm going to put y, right, in one column, and y3 in another. Let's see if this works. There we go. So we have now 2 columns, right? Now watch if I just plot x, which is just one column, and then I put yr, what happens? It actually plots both of them. So that's can be useful. I personally like to put the hold on and plot things, you know, just one by one. But that is what will happen. And notice that it didn't need x value to be the same size as the YR, because the YR has 2 columns, right? And say 100 rows, whatever the size is. It didn't need X to be 2 column and 100 rows. This is one of the cases where it doesn't need it to be the same size. All right, well, I encourage you to play with all of this. Remember, you have an assignment from Chapter 2. Read Chapter 2. There's tutorials on MindTap. All of that's linked on Moodle, so you can go see. You have, oh, sorry, this is Chapter 3. You have an assignment for Chapter 3. You have some extra tutorials that you can look at for Chapter 3, all on MindTap. You have a quiz for Chapter 3. Okay, so, well, we'll see you next time for Chapter 4.